many of us have experienced problems with waterproofing measures in buildings, particularly if there's basements involved. That may be down to design issues. It may be down to the specifications. More often than not, it's construction defects and bad practice. And a person who knows all about that sort of thing, a lot more than me, that's for sure, is Rob Dolman of Sovereign Chemicals, who I've persuaded to join us today to talk to us for 45 minutes or so on the subject of structural waterproofing. Now, I'm told Rob's a devilishly handsome chap, but we'll never know because unfortunately his webcam's broken. So you just have to imagine. Anyway, without further ado, that's your lead in, Rob. I'll let you take it away. At the end, we will, as usual, invite comments on chat. So if you've got any burning comments, put them in there, and I'm sure we'll have some time to go through a few at the end of the presentation. Okay, I'll shut up.
Lovely. Thanks, Trevor. So yeah, the next 40-45 minutes or so, we're going to be covering structural waterproofing. And yeah, as Trevor said, any questions, feel free to shout out at the end. So my name is Rob Dolman, CSSW qualified. For those that don't know, CSSW stands for Certified Surveyor in Structural Waterproofing. And I'm the National Waterproofing and Ground Gas Protection Manager for Sovereign. For those that don't know who Sovereign are, some of you might know Sovereign from back in the 80s and 90s, where we were just a damp-proof company. But for the past decade or so, we've revamped everything. We've been brought out by Bostik, who are still around, as someone mentioned earlier. Yeah, we've been brought out by Bostik, so now we're into the field of waterproofing, ground gas protection, and masonry and structural repairs as well. So just a bit of an overview of Sovereign. We've been manufacturing out of Barrow and Furnace for over 50 years. We're now part of the Bostik company, who are ultimately as well owned by Arkema. Because we're now part of Bostik, the manufacturing facility is moving from Barrow to a more central location in Stafford, which helps logistically as well, because getting to Barrow can be a bit of a nightmare for deliveries. We do have an ever-growing team, so we have a large team of technical and sales staff. I think the technical team is up to about 7 now, and the sales staff is up to about 11. So we have about 18 or 19 people out on the road 4 or 5 days a week. So these numbers are probably slightly out of date now. So we do well over 800 individual specifications and probably double the amount of site visits, because as you can imagine, 18 people out on site visiting 10 sites a week, for example, it's a lot of sites every week. And unfortunately, these seminars now are on webinars. You know, we would like to come face to face and to the office, but the webinars seem to be working out quite nicely. So what we're going to cover over the next 45 minutes, fundamentally why to design a basement. So there'll be a quick slide on the benefits of constructing a basement. The 4-point philosophy of waterproofing. So if you're going to take anything away from today's presentation, screenshot that. It's very important. We're going to look at all the design considerations, quick overview on flotations of slabs, all the relevant documents and standards, and a heavy focus on BS 8102 2009 and the NHBC Chapter 5.4. We'll also review all the waterproofing systems, and unfortunately, obviously there are some failures, so we'll quickly go into why the systems do fail, and then other considerations with regards to external drainage and construction joints and the like. So quickly, why to design a basement? Fundamentally, a lot of places, are densely populated, such as London, Manchester, or other densely populated cities. So there isn't as much room to extend out. So a lot of people are going below ground now. But basements are up to 10% more thermally efficient than above ground stories. We always have to consider the whole life cost of a basement as well. But we also consider the use of eco materials. So all of our products, a lot of our products, are made from recycled materials, and the likes of our plastic membranes and sheet membranes and our cavity drain systems are recyclable as well. So the 4-point philosophy of structural waterproofing, which is taken from the Waterproofing Bible, 8102, It must be assumed that groundwater or hydrostatic pressure will be present at some time during the structure's life. So basically what that is saying is, regardless of what the water table is saying in the report, if the water table is saying it's a permanently low water table, we still have to assume that groundwater is going to bear against that structure at some point during its life. Second point, we must assume that defects will exist within the system. So we have to assume that you're not going to get the perfect build, or you have to assume poor workmanship. Something might happen, the membrane might get punctured, for example, and we have to take that into account. The consequence of these defects or leaks must be considered. So what is the consequence of failure? So for example, the consequence of failure would be a lot higher, for example, if it's an underground Microsoft data center, for example, compared to a multi-story car park that's below ground. So the consequence of failure is very much worlds apart, if you like. And then the last point in there, if the consequence of these defects is unacceptable, such as a flood, then remedial works must be considered. So system must be accessible. So what that's saying is there means of repair? Can you repair the system if it does fail? And a prime example of this is, a lot of contractors would waterproof a basement from the outside or the external. If that does happen, how are you going to fix it? So is there means of repair internally? Because you're not going to excavate tons of earth to repair it externally, and so you're going to repair it internally. So is there means of repair internally? And we'll come on to that as well in a few slides' time. So in essence, from those 4 points, all basements should be designed with the acceptance that defects can occur. So they always you have to have that backup system in mind. So some design considerations. We have to look at site suitability. So the soil conditions, the water table, as we mentioned. The soil conditions will let you know if the strata is free draining, or there's going to be bands of clay which could affect the movement of water. The water table, even though we know that we have to assume that water is going to bear against the structure, the water table still gives you that risk factor. So we know that if it's a permanently low water table, we know that the risk is significantly lower than if it's a permanently high water table. So within the geotechnical report, it will mention things such as any ground gases or contaminants are on site. So even though 8102 is regarding structural waterproofing, there are some crossovers between 8102 and BS 8485, which is for the protection of methane and carbon dioxide. Construction method and materials. So we know that a reinforced concrete shell is for us anyway, from a waterproofing perspective, is a better material to use for an underground basement than it would be if you're using like a blockwork construction. Structural considerations, that's the main one is to do with slab flotation, and we'll come into that in a few slides' time. The building regulations, that's part C. Waterproofing systems and BS 8102, that's the waterproofing Bible, BS 8102. It's currently being rewritten. I myself and a few other members within the manufacturing fraternity with waterproofing are involved in rewriting BS 8102. And that margin for error, and I've put it in brackets there, the Outwing case. Now, I don't know if anyone remembers or knows about the Outwing case, but it was a historical case back in probably the late 90s or early 2000s, where no margin for error was taken into account with the design or installation. So an architect designed a waterproofing system, the contractor installed it, but didn't follow the architect's design, but both designs were wrong. So either way, so who's to blame basically for that error? And it's a historical case really, because that's when the British standard got rewritten, and then that's where we brought in the margin for error. So I'm sure we're probably all aware of construction method and materials, but we'll quickly run over them anyway. So the majority of the time we see basements being constructed from reinforced concrete or blockwork. We try and, if we get involved at the early design stage, we do try and push people down the reinforced concrete route. But we see just as many basements or retaining walls being made from blockwork as well, and hopefully in better prep work than the one on the right there. Bit of a buzzword at the minute. So ICF, insulated concrete formwork. For those that don't know what ICF is, basically it's a polystyrene shell, and the cavity is filled with a concrete. This then creates your retaining wall. The argument then is, how do you actually waterproof it. So ICF companies don't really like things being stuck to it, so you can't really use tanking or a membrane as such externally. So what we tend to go with is fill the void with a waterproof concrete mix, and then internally you have a drainage management system such as a cavity drain system. So if there is any water, you're going to be able to manage it away. But ICF is becoming increasingly popular. And then there's a whole host of pile construction, so contiguous interlocking, so you can, and then we've got sheet piling as well. Now, sheet piling is actually a form of waterproofing, believe it or not. So sheet piling comes under the Type B category, and we'll cover all the different types in a few slides' time. But it doesn't really get used as much because Type B is predominantly waterproof concrete. But if you have a sheet piling, if you weld the cleats, it is actually a form of waterproofing as well. So what we meant with flotation of floors. So this is mainly to do with a structural engineer, really. We wouldn't necessarily get involved with the design of the slab or the concrete itself. But there is a risk of basement slabs going into flotation. So I think the calculation is if the water table is 2.5 times higher than the thickness of the basement slab, there's a risk that the slab could go into flotation. So for quick maths, if the slab is 100 mil thick, but the water table is 250 mil higher than the slab, there's a risk it might go into flotation. And then, you know, potentially that happens. Obviously, it's a bit of a dramatic photo, but it does happen. I've come across probably 2 sites in the past 15 years where it's not as bad as that, but you're walking on it and it does feel a bit wobbly. It feels a bit spongy like. But basically, you know, the slab itself needs to have some resistance to the water, so it has to be able to withstand some hydrostatic pressure. Otherwise, you know, potentially this can happen. So we've mentioned building regs. So Part C is the one that's relevant for waterproofing. Part C is also relevant for gas ingress as well. And this is the site preparation and resistance to contaminants and moisture. So basically keeping contaminants and moisture from entering a building. Doesn't really go into too much detail with regards to how to go about it. We mainly focus our attention towards BS 8102. Like I said, this is the waterproofing Bible, if you like. We refer to this for all of our jobs. And this is the code of practice for protection of below ground structures against water from the ground. It goes into a lot of detail with regards to the different forms of waterproofing. So waterproofing barrier materials, structurally integral, as we've mentioned there, with the sheet piling and waterproof concrete. Drained cavity construction, which is a water management system. Incorporates external drainage as well into all of your designs. But it's not just basements that this is concerned. It's concerned with any form of structure that extends below ground level. So it could be a podium slab, which, you know, a podium slab is basically the roof or the lid to a basement that extends out of the property. So it's above the basement is external, if you like. So even though that's only probably 200 or 300 mil below ground, that's classed as waterproofing as well. 8102 also goes into a lot of detail with regards to who you need to get involved as well. So it advises the inclusion of a waterproofing specialist. This person usually has the accreditation of a CSSW, but this person, to get the CSSW, you can't just walk into it. You need to be in construction for at least 5 or 6 years. So you need to be suitably experienced to get it. Yeah, the pass rate of even getting the CSSW is, I think, is something like 15 or 20%. There might be someone on this call here with the CSSW qualification. But this person should be suitably experienced, be capable of devising solutions, because there's going to be different project constraints and needs, not geographically, but you know, different needs with regards to the client as well, so different grades of protection. But also to provide the design team not only with the information and guidance for the design stage, but also whilst you're on site for installation, for future maintenance as well of the waterproofing structure, because some elements of waterproofing do require future maintenance as well. But it's also worth bearing in mind that the waterproofing design specialist could actually be the manufacturer. So Bostik or Sovereign Chemicals, we can actually be the waterproofing specialist on a given waterproofing job. So the environmental grades, as outlined in 8102, go from 1, 2, and 3, which basically mean wet, damp, and dry. So a grade 1 basement basically means a wet basement. Now, no one really wants a wet basement, but that is the performance level. So if, for example, if you've designed to a grade 1 spec and you put your hand on a basement wall, you're allowed physical running water to run over your hand, so seepage is allowed. The intended use of a grade 1 tends to be somewhere where it can be wet, so a car park or a plant room that can be in a wet environment, or workshops. However, for the past probably 18 months or so, I haven't really come across many grade 1s now. So a lot of grade 1s are being put into a grade 2 environment. So a grade 2, as we mentioned, is a damp environment. So the waterproofing has probably been, has been beefed up a bit compared to a grade 1 environment. So the damp areas there, you're not allowed any physical running water to run over your hand, for example, so no seepage, but damp areas are tolerable. Now, the only difference between grade 2 and grade 3 isn't necessarily the waterproofing design. So the waterproofing could actually stay the same for a grade 2 and a grade 3. The only difference is the introduction of ventilation, air conditioning, dehumidification to get rid of that water vapor, to get rid of the damp patches. That's the only real difference. Prior to the 2009 edition of the 8102, there used to be a grade 4 environment, which was for archiving, but now that's all in with grade 3. So there's only 1, 2, and 3 grades now. So as well as the environmental grades 1, 2, and 3, we also have forms of waterproofing or types of waterproofing, which come as A, B, and C. So a type A protection is what we commonly known as tanking, or external membranes, internal membranes, but not all type A membranes can be applied internally without being sandwiched. So the types of barrier protection, type A membranes, are bonded sheet membranes, such as post-applied self-adhesive, where you remove a release film and you can stick it on with some primer. Composite sheet membranes, liquid applied membranes, GCLs or geosynthetic clay liners, they are still being used. We don't promote the use of them because it's old technology. It's from the 60s and 70s, so we don't do them per se, but they're still out there and readily used. Master cash belts are still used. And then there's two types of cementitious renders as well. So there's a standard cementitious render system, and there's also a crystalline active slurry as well. So here at Sovereign, we have the bonded sheet membranes, liquid applied, and then the two renders at the bottom. The reason why we promote the use of the render system is because if we go back to this picture here, and you can see the two thick black lines, this is being applied externally, and then internally is this thick black line here. So the render system is the only system that can be applied internally without being sandwiched or without being loaded against it. Because if you have a bonded sheet membrane, for example, a self-adhesive membrane or a liquid applied membrane, it can't take any negative hydrostatic pressure. So there's a risk of the membrane being pushed off the wall. That's why you have to sandwich it. So the render system is the only one that can be applied internally without being sandwiched. Type B, as we've mentioned earlier, structurally integral protection. 95% of the time, this means waterproof concrete. So waterproof concrete, there are two types of waterproof concrete. There's a hydrophobic system and there's a crystalline system. both systems, effectively, you get a waterproof concrete shell. But the difference is, hydrophobic system, once the shutters are striked and once the concrete's cured and up, the concrete is waterproof. With a crystalline admixture, fundamentally it's all the same, but once it's cured, it actually needs further moisture to pass through the system to reactivate the unhydrated crystals within the concrete. These crystals then expand and block the capillaries within the concrete. The great thing about crystalline, though, is that it's actually self-healing as well. So if there are any cracks within the concrete, I think it's up to 0.4 or 0.3 mil, these cracks will heal themselves. When you are on site though, and the concrete arrives, it looks and acts like normal concrete. So you won't know the difference between standard concrete and a waterproofing concrete mix. It arrives the same, from the batching plant. It pours exactly the same. There's no special health and safety handling procedures, and it behaves like normal concrete as well. The only difference is when it cures, it's actually waterproof. And then we have a type C, which is drain protection. And as you can see from the image, it's a fully internal system. What this allows is for a backup system. It can be used on its own, but predominantly it's used as a backup system. So if any water does come through, as you can see from the image, it's like an egg crate system. So if any water does come through, it can trickle down to a perimeter land drain, and the same for the slab as well. If any water migrates to the slab, it can be drained and fall down to the perimeter land drain. This is how it looks in photos. So it's usually an 8mm studded membrane on the wall and a 20mm on the floor, all taped and sealed, and it's plugged on the wall as well. It does need to be rodded and maintained, as we've mentioned. So there needs to be rodding points. These are usually access points, through manholes, or they can be internal access points as well. And as you can see from this picture here, this is the perimeter land drain as well. So the 8mm membrane flies past it around the back, and then the 20mm goes over the top. The perimeter land drain can either sit within a rebate within the slab, which is our preference, to be honest, or it can sit on top of the slab. The reason it's our preference is because if you rebate it into the slab, you can quite easily get the 20mm to go over. If it's on top of the slab, you're limiting yourself to 20mm of water to go through into the channel. So we always advise on having a 3mm membrane on top of the insulation, just in case any water does, if excess waters want to come through, it can be collected with the 3mm membrane on top of the insulation as well. The primary resistance, though, has to come from either the structure itself or another form of waterproofing. So 2 examples. If it's a retrofit basement, for example, an existing cellar, an existing basement, the primary resistance predominantly has to come from the existing basement. So if there are any leaks or if there's any seepage, those leaks have to be plugged first. So for example, this is where maybe a render system might come into play. You could render the walls first and then apply the CDM system. If there's no leaks, just some minor damp maybe, then you can apply the cavity drain system straight onto the wall. In a new build scenario, you'd probably go for an external membrane or waterproof concrete, and then the Type C or the cavity drain system internally as a backup. Always flood test the slab before you fit it out to make sure that the water's draining and there's no ponding of water. As with all membranes, as well as the Type C, if there are any penetrations, these all need to be sealed round using a tape system or a rope system. So the rope is ideal for smaller penetrations, and then we have the wider tape for larger penetrations. If it's a full basement, then the chances are you're going to need to have a sump and a pump system. If it's only a partial basement, such as one retaining wall, or it's set into a hillside, so it's on a sloping site, you might be able to get away with a gravity-fed system. But for a sump and pump system, we follow the HBC guidelines, which states that you have to have a primary and a secondary pump. So always have 2 pumps in your sumps. And then one of those pumps has to have a battery backup and an alarm. The PCA or the Property Care Association only really recommend 2 pumps and an alarm, which is usually adequate. But if there is a main shortage or there's a power cut, and you've got water coming in, the system's going to fail. So we always recommend a battery backup as well. The only downside, I suppose, to the Type C system is that there is the need for ongoing maintenance. There is a page coming up on maintenance, but we do recommend that you set up a maintenance agreement with the contractor or the pump supplier. I think it's the first 6 months it needs to be maintained at least once, and then thereafter it's an annual thing, so every 12 months. But I always recommend to the homeowner or the client, shove a Calgon tablet into the system. And people do laugh, but Calgon does get rid of limescale. So, and that's what we're trying to prevent. We're trying to prevent a limescale buildup. So, if it can work in your washing machine, I'm pretty certain it can work in your Type C system. A brand new product we've brought to market recently is the Danapen 500. This is an insulation board. It's a closed cell insulation, so not only is it more thermally beneficial than open cell, but because it's a closed cell insulation, it can actually also act as a vapor barrier, and it can also get wet. And what I mean by it can get wet is that it can actually be applied on the wet side. So it can either be applied underneath the slab, or it can be applied on top of the slab with the waterproofing on top of it. So as you can see, it's got grooves in the insulation board. These grooves would sit on the slab, and then that provides the drainage pathway to be, you can manage the water away then to your perimeter channels. We do offer guarantees. The guarantees is a new scheme we've set up called the Asac Scheme, which is the Association of Sovereign Approved Contractors. Most warranty companies, such as HBC, LABC, Premier Guarantee, they would require a 10-year guarantee, which covers installation and materials. And we offer this to our Asac members. So if someone wants to have a 10-year guarantee from us, it would have to be part of our Asac scheme. Moving on to chapter 5.4 then, and other warranty companies, because most warranty companies now follow the same suit. So the differences between what a warranty company would want and what the British Standard want are very similar. However, there are some grey areas within the British Standard, which this new chapter 5.4 actually goes into a bit more detail with. So within BS 8102, it states that we advise that you get someone with CSW qualification or a waterproofing specialist. The chapter 5.4 actually states that a CSW qualified person needs to undertake the design responsibility for the waterproofing on any given job. So if you've got a waterproofing job, it has to be done by a CSW qualified person. For grade 3 protection, and as we should all know by now that grade 3 is a dry habitable space, 2 systems are required where the ground walls retain more than 600 mil. So basically, if you've got a basement and it's a new build, you're going to need 2 lines of defense. The difference with BS 8102 states that consideration should be given to a combined system. It never actually states that if you've got a basement deeper than this, or if you've got a retaining wall deeper than this, you should use a combined system. Chapter 5.4 actually goes into that much detail. As is stated as well, 10-year insured guarantee from a specialist waterproofing contractor to cover materials and installation, which we do. And all of our products are BBA certified as well. Just a quick selection of our BBAs. So we've got our Hydrophilic 11, which is the render system. The Sovereign CDM8 lath membrane, which is the mesh membrane that goes on the wall internally, which is the same as the one on the right. So it manages water away. The difference is the one in the middle there, the lath membrane, you can actually plaster straight onto it because it's got a mesh grid on it. So you can plaster straight onto it, you can dot and dab straight onto it. The one on the right, you do need to have battens and you need to fit it out. Other considerations. So construction joints, these are weak points within the structure. So they do need to be waterproofed and looked at carefully. So all construction joints within that are in a waterproofing scenario should have a water stop of some sort. And there's 2 types. There's the passive and the active water stop. So a passive system is literally a physical barrier stopping water migrating through the construction joint. This can come in as a rubber or PVC. The one that we do are steel water bars. The one on the top right there, that yellow, is a PVC water stop. But then there's the active ones as well. So we've got the hydrophilic strips, crystallization slurry, the post-injected system, and a permeable hose. We do 2 out of those. So we do the hydrophilic expanding water stop, which is the picture on the left here. What this does, you set it in place in a little rebate as shown there. Any water that does come through that construction joint, the hydrophilic strip expands when it gets exposed to moisture, and then so it blocks the pathway for any water to come through. The other one that we do is the post-injected system, which is the one on the bottom right there. And basically, it's a little hose pipe that gets put into the construction joint, and then you post-inject a waterproofing grout into that, and it seeps out into the construction joint, making the construction joint waterproof. This is a great 3D image actually on the right. It's a typical kind of new build application really. So a concrete shell with a water stop at the construction joint. Internally, we've got the CDM20, which is draining down to the perimeter channel. We've got the CDM8 membrane on the wall here. Now externally, we have a pre-applied membrane underneath the slab and toe of the foundation. On the wall, we have an external membrane, but also external drainage board going down to an external maintainable land drain. And we'll cover the external drainage in a few slides' time. Just a quick mention on ground gases, because it does state in 8102 that the insertion of a ground gas barrier for the prevention of ground gases and contaminants from entering a building or structure should be considered. So if we're considering water ingress into the building, we should also be considering any contaminants as well. This is covered in a lot more detail in BS 8485 2015. And 8485 goes into a lot of detail with regards to methane and carbon dioxide, and it works off a point scheme. Radon is covered by the BRE documents, and then man-made contaminants such as VOCs and hydrocarbons, vapors and liquids is covered in the Syria documents. We've got a quick slide here on radon gas. So it's a naturally occurring, colourless and odourless radioactive gas. It's actually present within all soil and rock within the UK, but there are hotspots of where radon is a problem. So you've got the southwest, Wales is a band going through the Midlands as well, up to the Lake District. And radon is actually the second largest cause of lung cancer in the UK as well. And there's actually it's quite simple to find out if you're actually in a radon area. There's a postcode checker online. You can type in your postcode, it'll let you know whether you're in a radon affected area or not. And it's down to you whether you need to panic or not, and if you've got a radon membrane underneath your slab or not. This is our liquid membrane that gets put on the walls. It's bright red to let everyone know this is a radon site as well. This doubles up as not only on the right there as a DPM, but also on the left there in the waterproofing scenario. So external drainage, this gets spoke about quite a lot within the 8102. These two images both show a waterproofing scenario. On the left there, we have a render system that's been applied externally. And on the right, we have what looks like a liquid or possibly a self-adhesive sheet bonded membrane. But both membranes have been protected with this geotextile membrane. So this geotextile membrane has two uses. So one, it protects the membrane or the render or the membrane, whatever is being applied. It protects it during the backfill, because when contractors backfill, they just, well, the backfill can be anything really. We tend to advise that the backfill should be free granular material, which can be quite sharp, so it can puncture the membrane. So this provides protection during the backfill, but it also provides a pathway for any standing water against the structure to be managed down to a land drain. Now, this land drain should always be at the foot of the retaining wall. It should be maintainable as well. And there is a correct position for a land drain as well. So the ideal situation is position 1. Try and divert it away from the structure. Position 2 is acceptable. So it's still away from the structure. It's still below the structural slab level. Where we always see it on site and where we always see it within designs is position 3. Now, position 3 is a big no-no, because as you can imagine, you've got your membrane and your geotextile fleece, and you're managing the water down to here. Now, there's usually a kicker joint up here, or it might be a kickerless construction. So there's going to be a construction joint around here. So you're managing water down to a weak spot, if you like. So you need to be managing water away. So 2 is okay, but you need to manage it as far away as possible. But we always see it at 3, and I've seen it up here before as well. This is what happens when the pumps and sumps aren't maintained. So we do advise you to set up a service schedule. They do need regular servicing. Like I said, for the first 6 months, it needs servicing once, and then thereafter every 12. And this is to comply also with BS 8102. A quick slide on failures then and why they occur. So the most common one is jointing, poor jointing, as you can see in the top 2 pictures there. On the right, top right, it looks like a render system that's been applied to a wall. Maybe they haven't used enough bonding agent, or it might not have been applied thick enough. And then in the bottom right there, we have a membrane that's just simply been punctured. Probably no fault of anyone's really, but it's been punctured. You've got water penetrating through. It can be bandaged up using a tape or a slurry system, so it can be fixed. However, if these things go unnoticed, that's when problems do occur. And then a just a couple of slides really on the Sovereign service and how we can help. So we do offer free design support. So we offer a detailing advice service, free CAD support as well. Face-to-face meetings, or they sound a thing of the past now. So we do Zoom meetings as well. We are getting out and about more now, though, as restrictions are being lifted. We offer sound specification advice as well. So we do have NBS specifications. We have a brand new interactive website as well, which our Asac members actually can log in with their credentials. They can order material directly from their phone in their vans on site and get it next day. And we do pride ourselves in having the best on-site support as well. So our support doesn't stop at the design stage. So we do have a strong on-site presence, so we can show contractors some installation techniques. We offer toolbox talks and just general on-site technical support as well. We have a brand new van as well that's going up and down the motorways as we speak, often on site. And this van contains hands-on material, so contractors can be shown how to lap a membrane, how to heat weld a membrane, how jointing works, how it's applied. There's also a large TV as well, so we can do these CPDs on site. We can show them videos on how to install things as well. More importantly, it's got a nice Nespresso machine on there as well, so everyone can stay hydrated. But fundamentally, we want everyone to make sure that our support doesn't stop at just the design stage. It's there for the site support and also the future maintenance. So hopefully what we've covered in the past 40 odd minutes or so: fundamentally why to design a basement, the 4-point philosophy of waterproofing, design considerations with regards to the risk assessing all the information on site and the soil types, water table. Look at all the documents and standards, including BS 8102 and Chapter 5.4, all the different types of waterproofing, so A, B, and C, the environmental grades 1, 2, and 3. And then look at all the other considerations as well with regards to construction joints and external drainage. If you are interested in the other presentations, let Rachel know or Trevor know, but these are the presentations that we do have. So we have a timber treatment, damp proofing, condensation. As we mentioned earlier, we have a ground cast presentation as well, which covers BS 8485, and then a structural and masonry repair as well. Thanks for your time. I'll welcome any questions.
Yeah, thanks for that, Rob. Really good. Really showed me personally how out of touch I am with the latest technology on the topic. We don't usually encourage our speakers to use bad language in their presentations, though, and I did catch you mentioning the phrase NHBC a couple of times, so maybe you can avoid that in future. Only they're wonderful, as we know. Have we got any questions so far? I'm not seeing any on the chat at the moment, so I might take the opportunity to ask one myself. While people are thinking about if they want to ask a question, do you come across many cases where land drainage provision is a problem because the outfall from that land drainage hasn't been thought through properly, so the water's not discharging away? In fact, it could be the opposite's happening, and the land drainage is bringing water pressure to the basement. Yeah,
potentially. It's I went to site a few weeks ago actually, and the land drain was positioned in a way that it was trying to drain uphill. Yeah, it can be a problem, but generally speaking, the land drainage, it doesn't seem to be the biggest problem really. If it's being installed, it tends to be installed correctly, but the problem comes from when you don't have any land drainage. So that's probably the biggest problem is not having it. When it's there, it tends to be installed correctly.
Okay, thanks for that. We've got a question from Dennis. I'm sorry I pronounced that totally wrong. I noticed. Oh, beg pardon. Sorry, I've lost it. I noticed that you advised 2 systems for new build with a retaining wall of more than 600 mil. Is this an actual requirement? And what about conversions? Should there be 2 systems for conversions?
Okay, so it's probably a couple of answers here. So 2 systems are always going to be required for a new build because it's going to be under a warranty provider. I won't swear again. it's going to be given
under an LABC warranty, possibly.
Under an LABC warranty. Yeah. The LABC and other warranty latent defects, they tend to require 2 lines of protection now. So for a new build system, it will require 2 lines of protection if the retaining wall is deeper than 600 mil, which most basements are. When it comes to an existing basement, that wouldn't really come under a structural warranty provider. So that comes under our discretion. So if we deem that the existing basement, we've done a risk assessment, and we think, yeah, you can get away with 1 line of protection, then we'll just stick 1 line of protection in. However, if water is coming through, we've plugged it, water's still seeping through, we probably will go with 2 lines of protection. So when it comes to existing builds, it's kind of down to the risk assessment and down to the designer. But when it comes to new builds, it's actually a requirement.
Excellent. Thanks. Good answer. Thanks for that. Another question from an anonymous or somebody called Mr. Guest. Assuming residential basement rooms, cinema rooms, etc., would fall under grade 3 walls, what is the typical build up, I guess, to be considered for such projects? Well, there's plenty of choice there, I guess, isn't there?
Yeah. So so anything that's habitable would fall under a grade 3. So whether it's a residential, whether it's offices, whether it's a leisure centre, basically anywhere that someone's going to be for some amount of time. So a habitable space, so that would cover cinema rooms as well. They all fall under a grade 3, which has to be a dry environment. Now, the typical build-up for these grade 3 projects would vary, and I know it's a bit of a sounds like a bit of a get out, but it can vary. There's so many different aspects that can affect the design, such as water tables, the type of construction being used, how deep it is, what's the level of risk involved. But it can go back to the previous question, really. So if it's a new build, the typical build-up will be 2 lines of defence. How those 2 lines of defence come about would depend on several things that are on site, really. So if you've got a sound substrate that's being constructed from concrete, you could get away with a type A membrane externally with a type C internally. If it's an ICF build, for example, we would probably encourage the ICF being filled with waterproof concrete and then a type C internally to that. So it does really depend on the situation, really. And I know that sounds a bit of an escape, really, as the answer, but it does vary.
Yeah, more than one way to skin the proverbial cat.
Yeah, exactly. Yeah.
Right. Well, I think that's dealt with the questions. So
Susanna had her hand up, Trevor.
Did she? I beg your pardon, Susanna. I didn't see that.
That's all right. I couldn't see where the chat is actually, but I've got a situation at the moment of an existing client who's existing builder in a client job where they've got a basement that's leaking. They're doing an extension in addition to the basement that's already there. It's a pumped situation, and they're not they don't want to uncover too much for fear of costing the customer so much money.
Yeah.
What's the sort of, you mentioned maintenance. I mean, that sounds like a good place to start to find out whether they had the pump maintained, and the Calgon tablet. After that, what do you think should be a good suggestion for them? Because the builder's at a bit of a loss as to how to deal with it.
Has the builder exposed the membrane? So do we know that it is a cavity drain system that's been installed?
He hasn't, and that's sort of, at the moment, it's obviously an existing home. I think it's timber framed on the inside.
Okay. And it's a basement. It's below ground.
Yeah, it's definitely blockwork walls because they've dug down to expose the existing to create the excavation for the new extension that's coming off the basement wall.
Okay. So there's a few things really. So it would be good to try and identify what waterproofing has been installed already. So you mentioned a sump and a pump system. So if there's a sump and a pump, the chances are, if it's been installed in the last probably 10 to 15 years,
yeah, it has.
The chances are there's going to be a cavity drain system installed. So there probably will be a membrane internally on the floor and walls.
Mm-hmm.
So now, if that is the case, we need to identify why it's leaking then. So why is that system failed? So a good point of call would be to check that the sumps are working, check that there's no blockages within the channels. Like I mentioned then, you know, if it is kind of getting clogged with lime scale, then we need to clean the sumps, clean the pumps, and maybe, like I said, put a Calgon tablet in the system. And
is that done through a maintenance contract or something?
Yeah, so there are a couple of we use a company called Eden Care. We don't maintain the sumps and pumps ourselves. We use a company called Eden Care.
Okay.
And they're based just outside of North London, I think.
Okay, that's good.
And
that's
they will
good.
come out and maintain it. But there might even be external reasons why it's failing, really. So it could be faulty rainwater goods, for example. Something as simple as that.
Okay. Yeah. Well, that's also, we're in a very high chalk, you know, hard water area.
Yeah.
So that's the pump getting blocked is quite likely. But
yeah. So it sounds like they need to try and identify where the leak's coming from. Maybe try and plug the leak if they can. If they can't, then they need to identify why it's failed. So maybe get someone out to inspect the system. And yeah, go from there. But you've got my details, so if you do need any help or anything, just give me a shout.
Okay. All right. Thank you.
No problem.
Excellent. Rachel, are there any other hands up that I'm not seeing?
Yeah, Craig. Craig has got his hand up.
Craig, fire away.
Yeah, it's just a quick one. With the system one, where you said about the stick-on tanking on the inside, like a bituminous stick-on or something like that, you said it has to be sandwiched due to water pressure. What would you say is the minimum requirement for it to be sandwiched, and how would you fix that as well?
Yeah, great question. So, so to answer the first part of the question, the way we would sandwich it would be to probably build a blockwork liner wall internally, probably leaving like a 30 or 40 mil gap, and then filling that gap with like a lean mix to sandwich it against the structure. So then you've got your type A membrane sandwich then, so it's not going to come off the wall. Now to maintain that, fundamentally you're not going to be able to maintain it. So technically it doesn't comply with BS 8102. However, doesn't mean it's a bad design. It just needs to be, you need to make the client made aware that future maintenance of this can't really happen. So if there is a leak, it's going to have to be plugged inside the blockwork wall. So you're going to have to wait till the leak comes through the blockwork wall and then plug it that side. Alternatively, the other option would be to install a cavity drain system internally on top of the blockwork wall. And then that's you've got future maintenance that way.
Yeah, because if you're putting a blockwork wall internally, you may end up with sort of a 3-skin cavity wall then, won't you? And it's obviously going to be eating into the room. So I'd probably say doing system 1 and 3 would probably be the best option, if that's okay as enough to be the sandwich material, if you like.
Yeah. So personally, the best option, if you are going internally with a type A sort of membrane or tanking, the best route would be to apply a render system, because then that doesn't need sandwiching. And then you can actually apply the cavity drain system directly over the top of the render system as well to reduce the space that you're going to lose. Because the reason for that is that if you render the blockwork wall and then you apply your cavity drain membrane on top of that, as long as you use the mesh version of that cavity drain membrane, you can then dot and dab or plaster straight onto that membrane then as well.
Well, that's really question well answered. Yeah, it's something we in building control, Craig, we come up across a lot, don't we, where you've got a ground level that's high and it may be just 1 or 2 walls, but we have to somehow work out a good tanking detail. And of course, the loading to the membrane is critical there, and a lot of builders forget that it's essential. So yeah, that was a good one. Any more, Rachel? Any more?
We've got Alexander Hopkins. You want to unmute yourself?
If you unmute and fire away. Are you there, Alexander? Otherwise, I'll go to another question.
Can you hear me?
Yes, we can.
Yeah. Yeah, if you're excavating a basement beneath an existing dwelling, so creating it by underpinning, do you still need to use a land drain? Just wonder what sort of details there are for that.
Yeah, I think in that situation, obviously having an external land drain is quite difficult due to the underpinning. So what we would then insist with regards to the design, we'd probably insist on having a fully internal system with regards to having a water management system internally. So go for the cavity drain system internally. So that gives you the maintenance, the maintainable aspect of design. It gives you a repairability factor. It also gives you basically fundamentally a land drain that's internal, basically.
Yeah, another good question. Thanks very much for that.
And just find Les. Question from Les.
Hi, just a quick one. Would you assume that there was water pressure at the face of the membrane if there was a land drain? On the basis the land drain, the primary purpose of that land drain is to take away the water pressure from the wall, so the structural engineer can design that retaining wall without water pressure. So if he doesn't need to take into account water pressure with the land drain, then why would the waterproofing system impose a water pressure under those circumstances?
Yeah, great question. It's a lot to do. There's a lot of factors in it because the water table can fluctuate. So if the water table does become high, it only needs to become high for a day or so, and if there's a crack or if there's a defect within the structure, water ingress will occur. Now, I don't know how that would affect the structural side of things, because could a structural wall be able to take the loadings of a hydrostatic pressure temporarily? I'm not sure. But with regards to the water pressure, if the water is going to bear against that structure and there's a defect within the membrane or defect within the structure, water ingress will occur. It's also down to flooding as well. So it's not necessarily sometimes the water table going up. It could be because water's coming down as well. You might have a flood situation, or you might have faulty rainwater goods as well. That can enter the building that way as well.
Yeah, on the structural side, you wouldn't, if the wall hadn't been designed for water pressure and water pressure was imposed, it wouldn't. I don't think it would create a collapse mechanism. It would certainly mean that the design would be eaten into the safety factors.
Right.
And if the wall was designed right on the limit, then yeah, perhaps there could show signs of distress. But like on majority of situations, if the draining of that water behind it is quite important, from a structural point of view. My theory was well, if it's not experiencing hydrostatic water pressure as a result for structural purposes, then why should for damp proofing? But you probably half answered the question. Is that there's probably even the smallest amount of the smallest defect, water will find, where that wouldn't necessarily be quite so critical on the structural side.
Yeah, and water also finds the path of least resistance as well. So it's not, like you said, it might not necessarily have an effect really structurally, but if you've got water up against a structure, it will find a way in if there's a defect. It's also worth bearing in mind as well that if you're in a permanently high water table area, we wouldn't actually recommend using a land drain. Yeah, because it's like sticking a land drain in the Atlantic Ocean. It's not going to do anything. So in that scenario, obviously you've got a high risk scenario anyway, so you're going to have to beef up the waterproofing, and ultimately a structural engineer is going to have to beef up the design as well, because you're going to have permanently high static pressure against the structure. So I think it's probably less of a risk structurally, but it's a high risk with regards to water ingress. So and I think since these warranty companies, won't mention any names, but since these warranty companies have introduced the 2 lines of defence for systems below ground, I don't think I don't know whether they have had any claims, but they've certainly reduced. I know that a particular warranty company begin with N ended in C. They had something like 10 or 15 million pounds worth of claims, of waterproofing claims, in the space of 10 years, and I think in the last 5 they've had next to none since this has been introduced. So it's clearly working.
Excellent. Thanks for that, and thanks, Les, for bringing in a
thanks, Les.
Perspective.
Yeah, thanks, Les. And Bostik still exists.
Yeah. Yeah. Right. Well, there was a couple more questions which we will pick up on in any feedback that we send out to post session. So sorry we couldn't get them all in, but I'll wrap up now. Thank you very much. If it was possible, there'd be a huge round of applause going, because I'm sure everybody else found that as interesting as I did. So thanks, Rob. Thanks for taking the time, and great to get such a big audience for you. I thought it would. Coming up, what's next on the CPD webinars with Hertfordshire Building Control? I see on the 15th of April, is that right, Rachel? We've got myself waxing lyrical again on the subject of what we call homes or houses in multiple residence, or HMOs as an environmental health person would call it. And we've invited in an old chum from Environmental Health who's going to speak to us about the Housing Act ramifications, and I'll do the Building Act ramifications. So that might be interesting to anybody who gets involved in that sort of thing. So hope to see you at that. Coming up also in the future, we will do something on Parts F and L when the new approved documents come in, when we find out exactly what format they're going to take. I'm always keen to wait till we see the finished article before we start delivering presentations on something which might not actually come to pass. And there's also a new approved document on overheating that we will do. So in a month or two, when we've got all that together, we will invite you to a CPD presentation on that to get you up to speed on the changes made. That's it then. All I can do, I think I wrap up now, unless there's anything I've missed, Rachel.
No, I think that's all. Thank you.
Everybody needs a Rachel to make up for their shortcomings. Thank you very much for joining us, and hope to see you again. Thanks again, Rob. Bye for now.
Thanks a lot.